Hi students, in this video we will discuss non-deterministic finite automata or non-deterministic finite state machine. Right, you know what is deterministic finite state machine? Right, it is a 5-tuple machine. It has 5 tuples Q, sigma, delta, Q naught and F. Right, and you know Q is total number of, that is set of non-empty finite states. Non-empty finite states, sigma is your alphabet, transition, Q naught and Q naught is your start state, F is your final state. For DFA, how will you write this transition? Q into sigma to Q. Correct, Q into sigma to Q. That is, we have discussed many DFA sums, right? Now I'll tell the difference between this non-deterministic finite state machines and deterministic finite state machine. And this non-deterministic finite state machine is also a 5-tuple machine where M is equal to Q into sigma, delta, Q naught and F. The only difference between DFA and NFA is there in its transition. This transition is for DFA, right? How will I write the transition for NFA? Q into sigma to 2 pi Q. Right? Now I'll tell what is the meaning of deterministic. Deterministic means, see, this is one DFA sum. You check here, I have 3 states, right? Each state will take both the inputs, that is, inputs is nothing but my alphabet symbols, right? And it will move to only one state, that is Q naught. When it takes A input, it is moving to Q1, right? Q naught taking A input, it cannot make a move to multiple states, right? It cannot make a move to multiple states. It can move to only one state. Whereas in NFA, right, Q naught, a state Q can take an input symbol and it can move to multiple states, right? After doing a sum in NFA, I'll show the difference between DFA and NFA with an example one more time very clearly. Okay. Now we'll discuss the first sum in NFA. I'll write the question. Question 1. Obtain an NFA to accept strings of A's and B's ending with AB. Ending with AB. Okay, obtain an NFA to accept strings of A's and B's ending with AB. Right? Designing an NFA is very easy when compared to DFA. Right? Whatever is given in the question as it is, you have to do. Right? What is the pattern given? AB. Right? So what you will do is like A, B. Finish your transition diagram. This is your final state. This is your start state. Number it Q naught, Q1 and Q2. What it is given, it should end with AB. Right? My string, it should end with AB. Ending with AB. But here I can have any A, any number of B's. Right? Beginning I can have anything. It is not necessary my string it should start with A. It can start with B also. B, A, B, B, A. But the condition is it should end with AB. Right? So ending with AB, here I will write A comma B. In beginning I can have any number of A's and B's. Right? Now I'll tell the difference. See, this is an NFA sum. Why it is an NFA sum? Check here, check the transition of Q naught, delta of Q naught comma A, right? Q naught, when it takes A, it is moving to Q1, and at the same time it is staying in Q naught also. See, for the same input A, right, it is moving to multiple states. But in DFSM, this will never ever happen. Deterministic. When a state takes an input, it will move to only one state. It cannot make multiple moves. Right? Since NFA is making multiple moves, right? The finite automata itself, it's known as non-deterministic. It is not clear. It is not deterministic. Right? But compared to DFA, NFA designing is very easy. Right? One more sum we can discuss. Obtain an NFA to accept the following language. Obtain an NFA to accept the language. Language is given as W such that A, B, A, B, N or A, B, A, N, where N is greater than or equal to 0. Right? I have to design an NFA for the given language W. What is W? My string. How I can form W? Using A and B. W such that W belongs to A, B, N or A, B, A par N. This B, N or A, N. Right? N, it should be greater than or equal to 0. Right? So, I can have N value equal to 0, or I can have N value greater than 0. So, if I have some 2 or 3 here, right, B to the power 2, it is like making multiple moves, right, saying in, right, many number of B's, here many number of A's, right, and here one more thing I have a OR here, so I should take a branch. So, how I'll write my start state? Q naught, right, first I'll write this A, B, A, B, A, right, B, many times, generating many B's. So, it is self, right. Next it is here A, B, sorry, A, B, oh yeah, it's there, A, A, right. So it is Q1, Q2, Q3, Q4, Q4, Q5, right. I'll tell once again A, B, A, B, A, B par N. So, I'll make a self loop A, B, A par N, A, B, A par N. So, I'll make a self loop. This is all about your NFA. So, this will be one final state. This will be another one final state. Right. One more sum we'll discuss. Question number 3. Right. Design an NFA to recognize the following language. Following keywords. NFA to recognize the following keywords A, B, C, A, B, D and A, C, D. Right. My NFA, it should recognize these keywords. It's very easy. How many branches I should take? I should take 3 branches. First is A, B and here it is C. I'll make this as final state. Next is A, B, D. I'll make this as final state. Right. Next is A, C, D. I'll make this as final state. right? Now number it. Q0, Q1, Q2, Q3, Q4, 5, 6, 7, 8, 9 and 10. Right, this is my NFA. So we have studied DFA, we have studied NFA. When compared to both, right, designing NFA is very easy. Whatever is given in the question, you have to write as it is. Only one thing you have to remember, when there is some repetition, right, when there is a repetition, right, I have to mark a self loop. Right, when there is a repetition, I have to mark a self loop. Right, here also ending with AB. So it should end with AB. So beginning I can have any number of A's and B's. Suppose if it is starting with AB. So what should I do? Starting with AB, here I have to mark a self loop. It should start with AB, but it can end with any number of A's and B's. So here I mark a self loop. So designing NFA is very easy. Whatever is given in the question as it is, you have to write. And you have to mark the self loop wherever it is necessary. Thank you.